All right, the magnetic compass. How does your magnetic compass work? Magnets are mounted on the compass card that align themselves parallel to the Earth's lines of magnetic force. What limitations does the magnetic compass have? With a jewel and pivot type mounting gives the float freedom to rotate and tilt up to approximately 18 degrees of bank. At steeper bank angles, the compass indications are erratic and unpredictable. What are the various compass errors? Let's review this from PPL training. We have oscillation error, deviation error, variation error, and dip errors. Oscillation, deviation, variation, and dip. Oscillation, deviation, variation, and dip. Oscillation errors, that's just the erratic movement of the compass card caused by turbulence or rough control technique. So the compass oscillates as it gets jostled around. That's easy enough, okay? Deviation error, due to electrical and magnetic disturbances in the aircraft. It's going to deviate a little bit because of things mounted into the aircraft. Variation error, remember this from your flight planning, angular differences between true and magnetic north. Reference isogonic lines of variation. So we always see that there's a 14-degree westerly or easterly variation or something like that, depending on where you live or where you're departing or arriving. All right, now the dip errors. The dip errors subdivide into other types of errors. So what types of dip errors are there? There's acceleration error, northerly turning error, southerly turning error, and that's it. So acceleration, northerly turning, and southerly turning. So for the acceleration error, remember ands. Accelerate north, decelerate south. So if you're flying on an east or west heading, when you accelerate, the magnetic compass shows a turn towards the north. And when decelerating, it shows a turn to the south. Accelerate north, decelerate south. Really, what you just got to remember is that the compass points north, and it always wants to be drawing towards north. And if you try to pull it away from north, it still wants to point north. All right. Northerly turning error. So as the airplane turns, the force that results from the magnetic dip causes the float assembly to swing in the opposite direction that the float turns, resulting in a false turn indication opposite from the direction of actual turn. So when you're flying north, and you turn away, it's going to go slightly in the opposite direction. It doesn't want to be pulled from its northerly heading. Because of this lag of the compass card or float assembly, a northerly turn should be continued past arrival at the desired heading by the lag correction value. Southerly turning error. When turning in a southerly direction, the forces are such that the compass float assembly leads rather than lags, resulting in a false excessive turn indication. And UNOS is the thing to remember here. Undershoot north, overshoot south.